I forgot these flip back and forth. So 1, 2, 3, come on. 1, 2, should be 3. Test points. 1, 2. Seven. This is 8. Three, 4, 3, 4. So this should be 5, 5. So 6. Okay. Realize something here. These little column driver circuits are laid out mirrored. So this one, there's the input. This one, here's the input. So when I was testing the column drivers, I was shorting the same side of all these resistors to ground. And that's why certain resistors got so much hotter than other ones, because I was having excess gate current going through the device and straight to ground, instead of going through the gate current limiting resistor. So that explains some of the heat issues I was seeing when I was manually testing this. Okay, now that I've gotten this all laid out, let's figure out where pin 1 goes. So 1 on here, I bet, goes to this chip. I'm guessing the output from that chip's right there. Let's just look it up instead of guessing. 7406. So 7406. Oh, I guessed right. There was that. I guessed wrong. Keep that out again. So A is the input, Y is the output. So pin 1 here goes there. So this pin right here is the driver for 1. Now, there's only so many places it can go, and I know it goes to this chip. So my row 1, goes to 4. Okay, let's see where 2 goes to. let's guess 3. Yep, 2 goes to 3. And these guys, I can actually see where they go. Or 1, 2, 7 goes to 2. This is 8 here. He's probably there. I bet he goes to 1. Yes, he does. Okay. Does he go? Yes, he does. He goes here. Goes to 8. 3 goes to 8, right? 1, 2, 7, 8, 3, 4. 3 goes to, which goes to, yep. So 1, 2, 7, 8, 3, 4. 4 goes to there. Input for 4 goes to 7. And this is pin 5. Pretty easy. Goes to here. Yep. And 6 goes to that. So 6 goes to 5, and 5 goes to 6. That's 6, and he goes to 5. Okay. So now at this point, I know once I'm able to address this latch, how the pins are laid out this way, and once I'm able to address this latch, how the pins are laid out to the column drivers this way. So now it's time for some addressing fun. Back to this diagram. The 273s have 2 control inputs. Enable, which when in the inactive state turns all the outputs tri-state, I do believe. Let me double check that. Don't need him anymore. No, I take that back. The enable pin, when active, turns all the outputs low, and the clock pin, when it's active, takes the data off the bus and latches it to the outputs of this chip. So pin 1 and pin 11 are the 2 pins I'm now interested in. And I'm just going to start tracing from this guy. Now, first thing I'm interested in is if pin 1 is just connected all the way across. It is. It's not. And it's hooked to 5 volts. So pin 1 is always high. Let's just double check it all the way across. The column driver is different. So for the row driver is different. So for the column driver, enable is just pulled up to plus 5 volts. Now power and ground on these chips is pin 10 and 20. So 10 should just be hooked to ground. And it is. Now, pin 20, which is circuit power, is not hooked to... No, it is hooked to 5 volts. I thought that was separate. The reason why I thought that was separate is there's this plus S right here. But now that I look closer, it is shorted to 5 volts underneath this cap. So plus S and 5 volts is the same thing. So there's no reason to treat them separately for any particular reason. Now, I don't know if at one time they had a version of this where these were 2 separate domains, because it sure looks like it the way they routed this voltage across the card, and it doesn't really intermingle with anything else. Use my thumb to find that. Yeah, that's just kind of really odd. Why? Why this row of chips is on a more or less separate domain. They didn't use that voltage to feed some of these other chips down below, but yet they shorted the two together. So maybe there was another version of this display that used higher current, higher voltage, something, and they populated a different driver chip in here in order to get, a higher voltage output, and needed to drive those chips from a different domain. But neither here nor there. Just sort of an oddity of this card. Short from the original designer, we'll never know. Okay, so power and ground are taken care of and marked out here. Now, what's next is clock pins, pin 11. Now I suspect each one of these is going to have its own, and they're not connected, so that matches up to expectations. Now the question is, where does... So there's pin 11 right there, and it runs up into this pin field, pops through right there, pops through right there, 2 rows in, comes down and hits that 138. Pin 1 is coming in on right there. Okay. 15, 14, 13, 12, 11, 10, 9, 7. For lack of a better... I can use the reference designators. I was going to say, for lack of a better description for this tree, I was going to number these guys, but... Okay, so this is U23. Which is a 138, 15, 14, 12, 11, 10, 9, 7. So 15, 14, 13, 12, 11, 10, 9, 7. This is bit 7 down to 0. Oh, 0 up to 7. So So this is U42, which is our last driver, and he's hooked to pin 12, pin 12. Which goes to pin 11 on U42. So how many groups of 8s do I have? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be the 12th group of 8. U41, I'm assuming goes to the same chip. Yep, one pin down. 9, 10, 11, 12, 13. Pin 13 goes to pin 11 on U41. U40. 14. U39. Pin 15. Yep. Okay, so this begs the question, where do the rest of these bits go? U38. So pin 11. Okay, so this used to go to tape. 10 used to go to U15B. Which was tape. He's no longer in use. Nine, nothing hooked on the back, and 7, nothing hooked on the back. 7 doesn't look like there's anything on the front, and 9 there doesn't look to be anything on the front. So these two might be unused, but 11 definitely goes somewhere. And unfortunately it goes somewhere very far away. So I'll poke these as we go along here just to make sure. But, you know, like we found in past ones, it could disappear. 1 up, 2 up. Oh, I think it goes right there. Or, oh, it goes up in here, flows to right there, I think. Yep. Flips on the back.